Hello and welcome to my channel. In this video we are going to learn integration of areas between a positive curve x-axis and the lines x equal to a and x equal to b. As you can see here, I have drawn a diagram. Here the curve which is above the x-axis, this is the x-axis, so the curve above the x-axis is called as a positive curve. If the curve is below the x-axis, if it is this way, then we call this as a negative curve. But in this case we will be concentrating only on the positive curve. So we are going to learn how to integrate the area between the positive curve, the x-axis and the lines x equal to a and x equal to b. So you can see the two coordinates I have drawn over here, a and b. So if I am going to draw two lines over here as x equal to a and x equal to b, then the two coordinates a and b represents the lines x equal to a and x equal to b. So this is a confined area which is between the curve, between the x-axis and between the two points or two lines. So with this basic knowledge, let us start solving this example. The finite region M is bounded by the x-axis and the curve with the equation y equal to minus x square plus 4x plus 5. The curve meets the x-axis at points A and B. Find the coordinates of point A and point B. So they have given the equation of the curve, which is y equal to minus x square plus 4x plus 5. Now in part A, they have asked us to find the coordinates of point A and point B. As you can see, the point A and point B are on the x-axis. That makes the y coordinates of these 2 points as 0. So what we will do here is, we are going to make, for this equation of the curve 4x plus 5, we will make the y coordinates 0. Because these two coordinates are on the x-axis. So once we make y coordinate as 0, we can rewrite this equation as minus, I'm going to take the minus common out from this equation so that x square becomes positive. So x square minus 4x minus 5. So I'm just rewriting the previous equation. So this becomes x square minus 4x minus 5 equal to 0. And now we can see that this is a quadratic equation. We can use the splitting the middle term for this quadratic equation, and we need to find out the factors of 5 which will sum up to give us negative 4. So I can find out two values here, that is x square minus 5x plus 1x minus 5 equal to 0. So I have used the splitting the middle term where I have multiplied 1 with negative 5, that gives me negative 5, and I should start finding the factors of negative 5 which when added or subtracted together gives me negative 4. So here the factor I got is minus 5 and plus 1, because minus 5 times plus 1 is minus 5 and minus 5 plus 1 gives me minus 4, which is the middle term. So making use of these two factors, I have split the middle term. Next is the factorization. That is, I'm going to take these two terms and these two terms. I'm going to take the common outs from these two terms. So x is common and in the bracket becomes x minus 5. And here we do not have anything common out, so we can take 1 as a common term. And in the bracket we have x minus 5 equal to 0. Now again from these two terms we have x minus 5 common. So we can write x minus 5 in one bracket and x plus 1 in another bracket. So the two values of x that we will get is x minus 5 equal to 0. Let us equate the factors to 0. And x plus 1 equal to 0, and here x becomes equal to 5 and here x becomes equal to -1 by shifting the +1 on this side. So we have got two values of x. So if we look at the diagram here, a is towards the negative x-axis and b is towards the positive x-axis. That means by looking at it we can say that a is at the negative x values. So a we can write it as -1 comma y coordinate is 0, and we can see the b is towards the positive x-axis. So here the value of x is positive, so we can assume that b is equal to 5 comma again y coordinate is 0 because they are on the x-axis. So we got the coordinates of a and b as it was asked in part A. Find the coordinates of point A and point B. Now in part B they have asked us to find the area of the region M. Now this is the region we are going to concentrate, and we have to find out what is the value of this region. For that we have to use the integration. So let us come over here. This is for part B, and let me draw the diagram again. Okay, this is the diagram. I have redrawn it over here. So to find out the area of that region, find the area of this region, we have to use a formula which is given as area is equal to integration from the lower limit to the upper limit y, that is the equation of the curve, dx. So here what we are going to do is integration. Now the lower limit is the negative value, so the area starts from this point and moves towards the positive side. So always remember, this is the lower limit and this is the upper limit. So here in a we had got the value of a as -1, 0. So here we are going to write down the coordinates -1, 0, and b we had got it as 5, 0. So we are going to use the x values over here because we had seen x equal to a to x equal to b, that is between these two lines. So x equal to a, so from -1 till the upper limit it reaches the upper limit 5. Y equation is already given here, so let me put in a bracket -x² plus 4x plus 5 dx. So let me start integrating these values. I'm going to separate individual terms. So integration from -1 to 5 -x² dx plus integration from -1 till 5 4x dx plus integration from -1 to 5 dx. So let us start solving this. So we get it as the integration of -x² is -x, the power becomes 3 because the power increments by 5, and the same power is repeated in the denominator, and it is -1 till 5 plus, here the integration 4 is a constant, so 4 will be as it is, and x to the power of 1, again the power increments by 1, so it becomes 2, and the same power repeats in the denominator, and write the limits -1 till 5 plus, and integration of a constant, 5 is a constant term, so it becomes 5x, and the limits are -1 till 5. I have discussed in details about the integration steps, the basics of integration, in this video. So if you are interested, you can click on the link and go through it before understanding these steps. Now moving forward, let us just start substituting here. Here as you can see, negative, it is 1 over 3. So let me take it out, take out the constants, -1 over 3. In the bracket, in place of x, first substitute the upper limit. So it becomes 5 cube minus the lower limit. Lower limit is -1. Again substitute in place of x. So -1 cube. So this is done for the first term. Now for the second term, plus, here you can see it is 4 times x square over 2. So let me just cancel these out because 4 and 2 goes in the table of 2. So they divide and it becomes 2x square. So I will take the 2 out now, which is remaining here. And inside the bracket, again I will substitute the upper limit, 5 square, minus the lower limit, -1 square. Substituted in place of x square. Finally, the last term, plus 5x. So plus 5 is a constant. Let me keep it out. And inside the bracket, in place of x, first the upper limit, that is 5, minus the lower limit, -1. So let me just simplify these ones now. It becomes -1 over 3. 5 cube is 125. And -1 cube is -1. So minus of minus is +1. Plus 2 times 5 square is 25. And -1 square is +1. So minus times +1 is -1. Plus 5. Then we get 5 minus of -1. So 5 plus 1. Further solving it, we get it as -1 over 3 times 126 plus 2 times 24 plus 5 times 6. So here we have 126 and 3 gets divided. So we have -42 plus 48 plus 30. So that gives us -42 and plus 48 is +6 and plus 30 is 36. So this is what is the area of this given diagram. So between point A till point B and between the curve and the x-axis, the total area of the shaded region is 36 units. So this is how we solve this example. Now let us look at another example. It also belongs to the integration of the area between a positive curve, x-axis, and the two given lines or points. So let us see what the question says. The graph shows part of the curve C with equation y equal to x square 4 minus x. The region A shown shaded is bounded by C, which is the curve, and the x-axis. Use calculus to find the exact area of A. First of all, in this question, they have already given you the coordinates, which is between 0 and 4. So this becomes your x equal to A till x equal to B. So this is your lower limit and this is your upper limit. Next thing, they have asked us to find the exact area of A. Whenever you see the term exact, remember that you have to get the answer in terms of surds or fractions or whole numbers. Do not get the answer in terms of decimals. Now since the coordinates are already given, we can directly go for finding the area. So area, the formula was integration from the lower limit till the upper limit y dx. So here the lower limit is 0 and the upper limit is 4 and the curve is given as x square 4 minus x dx. Now to solve this, we have to expand the brackets first. So integration from 0 to 4. X square times 4 gives us 4x square and x square times minus x gives us minus x cube. So let me put them in the bracket and dx. Let me just split them as independent terms. So integration from 0 to 4, 4x square dx minus integration from 0 to 4, x cube dx. This minus is taken over here. Now the regular integration steps. 4 is a constant, so 4 is kept the same way. X square becomes x cube over 3. The power is incremented by 1 and same repeats at the denominator. And put the limits, it's from 0 to 4. Minus x cube integration becomes x to the power of 4 over 4. And again put the limits from 0 to 4. Again we can see that 4 over 3 is a constant, so let me keep it out of the substitution, and inside the bracket in place of x cube I'm going to substitute the upper limit, so 4 cube minus, because it is upper limit minus lower limit, and x cube, put 0 in its place, it becomes 0 cube. Then there is a minus here, minus, it is nothing but 1 over 4. I can take it out, and inside the bracket substitute 4 in place of x, so 4 to the power of 4 minus 0 to the power of 4. So here we get 4 over 3, and 4 cube is 64 minus 1 over 4 times 4 to the power of 4 is 256. So let us calculate and see how much we get. So it is 4 and 3 multiplied with 64 minus 1 over 4, then multiplied with 256. So we get the answer as 64 over 3. So write here as 64 over 3. Do not change it to decimals because they have asked the exact area to be found. So if you have got it as a fraction, keep the answer in terms of fraction. This is your final answer. So remember to use the formula if the area is asked between a positive curve, the x-axis, and the two lines or 2 points. This is the formula to be followed. And these are the steps. Hope you have understood and liked my video. So if you're liking my videos, like, share and subscribe to my channel. And thanks for watching.